All right, so we're gonna get rolling here on the 4-4 notes. Now, what's kind of weird here is we just finished up multiplying and dividing rational expressions, and now we move to adding and subtracting, which in most cases you're like, well, wouldn't adding and subtracting be easier? In this case, that is actually definitely not the case. So this says our goal here is going to be add and subtract rational expressions. All right, so the thing you got to remember about adding and subtracting fractions is they must have a common denominator. So let's make ourselves a little note here. To add or subtract fractions, you must have a common denominator. So we could just talk about a super simple fraction problem, from that you would have done in probably like, I don't know, 5th, 6th grade, something like that. Like let's say you wanted to add 1/2 plus 3/4. Let's go 3/5. Let's pick something a little weirder. So in order to add two fractions like this, you need to create a common denominator because these are not. So in this case, the move we usually do is we take whatever this denominator is, and we multiply it by 5/5. You take whatever this denominator is, and you go 2/2. So that's going to change what these look like, but it's not going to change their values because you're just multiplying them by 1. So now this fraction would be 5/10, and then we'd add that to 6/10. And the way adding fractions work is if you have 5/10 and you add 6/10 to it, you now have 11/10. You do not have 11/20 or anything like that. Think of the fraction kind of like a unit. If you had 5 cats plus 6 cats, you would now have 11 cats. Instead of cats, we have tenths in this case. So you basically just add or subtract the numerators, and the denominator will stay the same. Okay, so that's your basic kind of adding or subtracting would be the same thing. If this was a minus, you would do 5 minus 6, and it would be -1/10. So adding and subtracting, not any more difficult one than the other. The key is, though, you have to have a common denominator. So what you're going to see today is some problems are super easy. Like A, it says, what's this sum? If you see a common denominator, then all you got to do is say, okay, I just got to do x plus 5, which is x plus 5 over x plus 4. And that's it. That's the sum. Now, with nearly all these, we should include any restrictions on the denominator. So again, in this case, our x cannot be -4. So, we do our little set notation here, just to indicate what number x can't equal. Anytime we're dealing with these rational expressions, that should be part of our answer. If we move on, you'll see these two are super easy also. Take 10 seconds and try them out. All right, so once again, nothing too crazy here. This one, all these have same denominator, so all you gotta do is add the numerators. So I did 10x plus a -4x was 6x. -5 plus 8 was 3. And then I did take this and factor it because I do want to see if I can reduce further. So I took the 3 out of these, but at that point, I didn't have common factors, so that's my simplified answer. And then I just listed the restriction. Can't be -3/2. Same process over here. X plus 3x is 4x. -5 plus -21 is -26. I factored a 2 out of here, and I got it down to 2x minus 13. But again, nothing canceled. So there's my final answer, and there's my restriction. X can't be -5. So I can't have a 0 down here like we've always had. All right, so now we move on here, and they say, what is the least common multiple? So what least common multiple is it's saying, hey, here's two things. In this case, we have the expression x plus 2 squared, and we have this quadratic here. They're basically kind of giving you the idea of, hey, if these were your two denominators, if you had, these were the bottoms of these fractions, what should we do to get a common denominator? And the phrase for this is a least common multiple. So in this real simple example we did, to make these common, we just multiplied them by each other. We did, times 5, times 2, and we were done. But this isn't always the move you'd want to do. Let's say, just for example, let's say you had like 1/2 plus 3/4. Well, in that case, you don't need to go 2/2 and 4/4, because to make these match, all you have to do is if you doubled this one. So if you just took this one and multiplied it by like 2/2, it's going to get this problem done much quicker. Now you'd have 2/4 plus 3/4. You'd be like, oh yeah, that's just 5/4. So the idea is we don't always have to multiply them by each other. Sometimes we can take a smaller piece to just to make them match right away. Now, that obviously with numbers is slightly different. So when we're doing it with variables, It just comes down to what their factors are. So in this case, this problem would factor to x plus 2 and x plus 2. This problem would factor to x plus 2 and x plus 3. So in order to get a common denominator, pretend these are denominators of fractions, if we needed to make these match each other, well, then I would need to give this one another x plus 2, and I would need to give this one an x plus 3. So overall, like what you would do to make these match is you'd say, okay, this one would need x plus 3 over x plus 3. This one would need x plus 2 over x plus 2. And now they'd have common denominators, right? Because you'd have 2x plus 2s and 1x plus 3 in the denominator. So that's our idea, is the LCM, the least common multiple between these, the smallest way you can make them match would be x plus 2, x plus 2, and x plus 3. So when you see that phrase least common multiple, it's basically getting at what's the best common denominator you could create? What's the most efficient one that you could make? And so that's kind of the process there. So let's look at this one and kind of think of it the same way. So really what this comes down to is you just want to get everything in factored form and then make sure that your least common multiple has all of those factors represented in it. So this one happens to have 3, which we don't do too many problems with 3 different denominators or 3 different parts, but here's one. So this would factor, you take an x out of this and you'd have x squared minus 9, which we should recognize is x plus 3 and x minus 3. Okay. And then this one, we could factor this to x minus 5 and x plus 3. And then this one, pull the x out and you got x and x minus 5. All right, so what's the least common multiple going to be here? Another way to look at this is you need every unique part, essentially. Everything that's different needs to be part of this. So it's got to have an x, and nothing has more than one x, perfect. It's got to have an x plus 3, which I already accounted for here, fine. It's got to have an x minus 3. Oops, sorry, minus. It's got to have an x minus 5. And that's going to be it. There's no doubles of anything like there was in this problem, how there was 2x plus 2, so we had to make sure we had 2 of them. Nothing has more than one of each of these factors. So this is going to be our LCM in this case. Basically, one of each unique factor there. Okay, so that's the concept behind LCMs. You're going to find that when you start doing these problems, you're going to get a lot better at this. You might not even think about it as a least common multiple, but we'll kind of get there as we go. Okay. A couple more LCM problems. Go ahead and try these out. See what you get. All right, so this one, once you got these factored, they have nothing at all in common. Every factor is completely different. So the LCM is just going to have to literally feature every single one of those parts. There's nothing in common to them, and so that's it for that one. And then this last one's actually a pretty tough example. So I went through and I factored everything. A lot of these you just have to pull the GCF out. And then if you have something like x squared minus y squared, that's just a difference of squares. So x plus y and x minus y. Here I pulled a 15 out of everything. And then I saw that I would just need a factor of minus 1s to get this 2 here, negative 2. So I just did my x minus y and x minus y. A little weird there when they throw that extra variable in there, but it is the same process as what you would do if there wasn't the variable there. You have to then just tack it on. And this one, x plus 2, y, and x plus y. So in this case, now I look at this for my LCM, and here we have a number. So if I look at 10 and 15, I say, what's the least common multiple? What's the lowest number that those can multiply to? That would be 30. Okay. And then we're going to need an x plus y. We're going to need an x minus y. We're going to need another x minus y because this problem has to have 2 of them. So you can either put squared or you can just put another one next to it. Same thing either way. And then we're also going to need the x plus the 2y. And that's a pretty tough LCM there. And what you're going to notice is sometimes these parts feel really hard. Then we're going to get to doing some of the actual problems. You're going to be like, okay, these really aren't all that bad. So with that said, let's go ahead and look at example 3. So now we're going to actually do the skill here, which is the adding. It says, what's the sum of these two things? So your steps for this, number 1, you got to create a common denominator. So I'm going to go ahead and get things factored out. So this denominator is x plus 1, x minus 1, difference of squares. We're going to want to add this to 2 over, and then factor this one. Let's see, we'd want to use minus 2 and minus 1. And then at this point, we take a look at those denominators, and we find that least common multiple. So they both already have an x minus 1. We don't have to add anything there. But this one's going to need the x minus 2. Okay. And this one's going to need the x plus 1. And once we do that, now we're going to be able to work this out. So what do we need to do here? Well, the way this works is you don't really need to mess with the denominator at all. The denominator is going to be what the denominator is. We don't have to factor it. We don't have to distribute it. We can leave it like this. We do actually need to distribute these parts though, because we're going to combine those like terms. So let's go ahead and do that. So let's say if we were distributing, we'd have x squared, we'd have a 3x, we'd have a minus 2x, we'd have a minus 6. Over here, we're going to have a 2x, and we're going to have a 2. And the reason I'm writing it all as one fraction now is we have that common denominator. These things match now, and so the denominator is just going to be this x minus 2, x plus 1, x minus 1. And like I said, you could distribute that out, but you don't need to. What we're really going to look at here is now that we're going to combine everything here, we're going to try to factor and reduce that if we can. So there's just a lot going on here. So what do we have as far as what are we left with? We have the 1x squared. We have a 3x minus a 2x, so that's 1x, plus another 2x, that's 3x. And then we have the minus 6 plus the 2, so that's minus 4. So there's my numerator. Over the same denominator, nothing changed in there. My last step of this problem is I need to look at it and see, can I reduce this further? Can this be factored? And in this case, if we look at that, it looks like we would use positive 4, negative 1. So x plus 4, x minus 1, yep, over x minus 2, x plus 1, x minus 1. And you probably see where this is going now. Just like other problems we've seen, this can simplify even further, and we can eliminate those. So our final answer is x plus 4 over x minus 2, x plus 1. Okay. As always, we can include the restrictions here. And remember, it's anything that's been in the denominator. So it's going to be, all these three zeros basically. So there's 2, negative 1, positive 1. Okay. All right, so this is what this is you're creating the common denominator and you're combining things, and then you're doing what we just spent all of last section doing, which is simplifying A expression. So we're not going to do B, but go ahead and try A on your own, and I'll work it out and you can check your answer. All right, so your takeaway here is these problems take some time. So the problem set today not going to be super long in terms of these type of problems, but I started it off same way. Got the denominators factored, and I created a common denominator. So I said they both already had the x minus 2's. So this one needs the x minus 3's. This one needs the x plus 2's to create a common denominator. I distributed my numerators and got it all kind of lined up there. Combined any like terms to get to here. And then I took this quadratic and I factored it. Once it was in factored form, I saw I did have a common factor that I could simplify by reducing those down and got myself to this final answer. Lastly, I went back and I looked at what was ever in the denominator and I found my restrictions. So you're going to see a lot of this today, just adding today, no subtracting, although we'll see tomorrow subtracting is not really much different.